Raindrops round us are falling, but for the showers we plead.
Before we commence the sessions, I would like to give you a few instructions. Dear participants, please mute your audio and switch off your video throughout the presentation to avoid inconvenience. If you have any questions during the presentation, please type them into the question box in your control panel. We will respond to your queries after the session. Now I invite Dr. K. Nirmala Jyoti, HOD of Chemistry, JMJ College for Women, to give the significance of the webinar.
A very good morning to all. It is my pleasure to welcome all the participants today for the 3-day international webinar on recent innovations in pharmaceutical and applied sciences. I welcome all the eminent speakers and guests from all over the globe from different walks of life who have come here to share their knowledge and vast experience with the community. I cordially welcome Dr. Sister Teresa Gade, correspondent of our college, Dr. Sister Shaini KP, our principal, distinguished speakers, Dr. Dasari Ayodhya, examiner of patents and designs, Ministry of Commerce and Industry, Tamil Nadu, Government of India on general synthesis, characterization and application of nanomaterials. Professor Ratnakaram Venkatnath, Professor, Chemistry, Department, Director, Admissions and Research Coordinator, Geetham, deemed to be University, Bangalore, Karnataka, India on chemical, biochemical and microbial advances in process industries. Dr. Susan Kumar Vadagoppula, PT, Physical Therapist, Dynamic Balance Physiotherapy, Vancouver, Canada on lifestyle modifications for better health and positive well-being. Dr. Raja Gorla, Senior Scientist, Dongbang FTL Limited, South Korea on advanced techniques and applications in pharmaceutical industry to achieve quality products. Let us know the significance of the day. The pharmaceutical industry has always played a key role in the progress of human lives. Health technologies push the boundaries of how healthcare is delivered and has the power to create breakthroughs in our understanding of diseases. The pandemic presented an uncommon situation for the healthcare industry as a whole, and the pharmaceutical sector rose to the challenges posed by the pandemic. Pharmaceutical innovation requires novelty of effectiveness. Pharmaceutical innovations create value to society by making it possible to generate improvements in patient health that were previously unattainable. It is the uniqueness of such health improvements that defines pharmaceutical innovations. As technology evolves gradually in every aspect of life, new innovations in the pharmaceutical field are showing revolutionary effects in the pharmaceutical fields itself. It's complete shift affecting everything from interaction of patients with the health systems to the way they are being provided treatment. Certain trends and pharma innovations are more often observed. Not only is innovation happening, but it is happening rapidly. To keep up the pace, the pharma industries are involving themselves with numerous technologies such as AI integration, big data, CMS, AR, and VR, digitization of medicine through healthcare mobile apps, IoT integration, blockchain, and 3D printed drugs, etc. These technology innovation in pharmaceutical are providing consumers a better solution in their everyday life. Today's session mainly focuses on the nanomaterials. Nanoparticles has occupied an eminent place in our tech facilitated society. The processes involved in synthesizing nanoparticles are important not only to find their applications but also to make them eco-friendly. Nanoparticles are suitable candidates for various commercial and domestic applications, which include catalysis, imaging, medical applications, energy based research, and environmental applications. In general, nanoparticle based technologies center on opportunities for improving the efficiency, sustainability, and speed of already existing processes. We hope this 3-day webinar would help participants expand their mental horizon and help them to gain experience and knowledge. I request all the participants to make use of these 3 days to the best of their abilities. Thank you, one and all.
Thank you, madam. Now I cordially invite our beloved principal, Dr. Sister Shiny KP, to greet the delegates and participants.
Happy morning to everyone. On behalf of JMJ College for Women Tenali, I cordially welcome you all to participate in this 3-day international webinar on pharmaceutical and applied sciences. I gladly welcome the eminent resource persons, Dr. Dasari Ayodhya, Professor Renagana Venkatanath, Dr. Susan Kumar, and Dr. Raja Golla for accepting our invitation to share their rich knowledge and expertise with the teaching fraternity. I congratulate the convener, Dr. K. Nirmala Jyoti, the head of the Department of Chemistry, Dr. V. the co-convener, and Ms. M. Shakina Kumari, the organizing secretary, and the faculty of Chemistry Department for organizing this 3-day international webinar on recent innovations in pharmaceutical and applied sciences. Coming to the topic, the pharmaceutical industry discovers, develops, produces, and markets drugs or pharmaceutical drugs for use as medications to be administered to patients with the aim to cure them or alleviate symptoms. Innovation is an important issue for the pharmaceutical industry, especially with regard to bringing new drugs to the market. Hundreds of studies on the industry are published each year, exploring the different trends and challenges in innovation in the industry. Hence, there is a need to create large public awareness about recent innovations in pharmaceutical and applied sciences, and the participants can gain new innovation theory on the pharmaceutical industry and applied sciences. With this view, to create awareness on the recent drug development and applied science technology, the 3-day webinar has been organized. I wish all the success and implore God's choicest blessings upon all the participants and the eminent speakers to have fruitful deliberations. Once again, I welcome you all to participate in this webinar and to have very enlightening and inspiring sessions.
Thank you, sister, for your warm greetings. Now I invite Dr. V. Sumalata, lecturer in chemistry, to introduce today's resource person, Dr. Dasari Ayodhya.
Good morning, one and all. Myself, I am B. Sumalata, lecturer in chemistry, JMJ College for Women, Tenali. It's my immense pleasure to introduce today's resource person, Dr. Dasari Ayodhya. Sir is working as examiner of patents and designs, Group A gazetted officer in Intellectual Property Office under Department for Promotion of Industry and Internal Trade, Ministry of Commerce and Industry, Government of India. Sir, having around 6 years of experience as examiner of patents and designs, and Sir examined 1080 patent applications including ordinary, conventional, PCT, national phase, and international search authority of the World Intellectual Property Organization, etc. Currently, SAR is also working in part of National Intellectual Property Awareness Mission, Government of India. SAR finished his MSc and PhD in chemistry from Usmania University, Hyderabad. SAR was a best research student during his PhD. He was published 51 research articles and attended 30 conferences, and 2 patents were filed. One book was published in the field of chemistry, that is in material chemistry. He is also working as a reviewer for review articles in various international publishing journals, including ACS, Biomaterials, Royal Society of Chemistry, Elsewhere Journals, Springer Journals, and Taylor and Francis Journal and Ville publications. Main goal of his research is eco-friendly manner to prepare various materials for use as prevention of environmental pollution. Thank you.
Thank you, madam. Now we are glad to invite you, sir, to take over the session.
Thank you. I'm audible to you.
Yes, sir.
Thank you for inviting Department of Chemistry, JMJ College for Women.
Sir, can you switch on your video? Can you switch on
Presentation,
your
sir.
video? No, video, sir, your video.
Okay.
Can you switch on your video?
Okay, sir.
Okay, sir, thank you.
Thank you for inviting Department of Chemistry, JMJ College for Women, Tenali. And my special thanks to Dr. V. Sumilata for her constant support to invited me. And now I am presenting my presentation in 3-day international webinar on recent innovations in pharmaceuticals and applied sciences. Okay, are you viewable to you?
Yes, sir.
Can I put in a slide share, sir?
Okay. Yes, sir, sure.
Okay, sir. Are you visible to this?
Yes, sir.
Slide?
General synthesis, characterization, that's right.
Yeah. Good morning to everyone. And myself, Dr. Dasari Ayodhya, Examiner Parent Design, Indian Patent Office, Chennai. Now, I am presenting the presentation in 3-day international webinar on recent innovations in pharmaceutical and applied sciences. That is a general synthesis and characterization and various applications. Not only catalytic and some various applications are there, including pharmaceutical applications and drug delivery systems and cancer treatment, and moreover inside of the medical field or biological field, in various applications are there in catalytic, photocatalytic and sensors. Lot of applications are there. Now in this webinar I am explaining about the what is the synthesis of nanomaterials and its characterization and its various applications. First thing, the overview of the nanomaterials. Overview of nanomaterials, these are the contents I would explain in this webinar. Introduction of the nanomaterials and how many types of nanomaterials and various examples and different synthetic methods to prepare various nanomaterials and its different characterization techniques by the spectroscopic techniques or analytical techniques and properties of nanomaterials. So what are the properties of nanomaterials before converting nanomaterials of the bulk materials also, and finally various applications of the nanomaterials. First thing, introduction about the nanomaterials. Nanomaterial is the when the bulk material will convert to nanoparticles or nanomaterials, the size is a major importance. Size is the grain size or particle size is important to conversion of the nanomaterials from the bulk materials. that is 10 power minus 9 meters, is converted to as a 10 angstroms is a nanomaterials. Before that, in 10 power minus 9 meters, that is a micrometer. 10 power minus 6 meters is called a micrometer. Only when the bulk material will convert it to 10 power minus 9 meter size, that is called nanomaterials. In general, nanomaterials are in a broad range, that is a 1 to 500 nanometers or 1000 nanometer. But in specifically, when the nanomaterials are called is 1 to 100 nanometer range only is called nanomaterials. Behind 100 nanometers, that is maybe mixed of the nano and microparticles. So only nanomaterials is the 10 power minus 9 meter in size, or 1 to 100 nanometer size is called nanomaterials. Then what is the importance of the nanomaterials compared to bulk materials? Bulk materials have no strong and hard ductiles and high temperature and corrosion resistance and wear resistance, are not chemically stable, and not surface area is not active. When it converted to nano from the bulk materials, those properties are enhanced, like ductile nature and wear resistant and temperature control and very chemically active, and majorly surface area is very enhanced compared to the bulk materials. When surface area increases, automatically the properties of the nanomaterials gradually increases. That's the importance of the nanomaterials compared to the bulk materials. And one more thing is also there, that is one more aspect in the nanotechnology, that is volume to surface ratio is important in the terms of nanomaterials. It is absolutely based upon the particle size and particular shape of the materials. Here, so I am showing some examples. Broad examples are there up to 10 power minus 1 is a 0.1 nanometers to 10 power 8 nanometers. But here the specific region is there, that is 1 to 10 power 2. 10 power 2 means of 100. 1 to 100 nanometer range nanomaterials are called in particular nano. Beyond the 10 power 2 or less than 1 nanometer is not called as a nanoparticles. Only the range of 1 to 100 nanometers. For example, these fullerenes and dendrimers, quantum dots, gold, not only gold, silver nanoparticles, all metal nanoparticles, and metal oxides, specified metal oxides, for example, zinc oxide, cadmium oxide, and copper oxide, iron oxide, tungsten oxide, and liposomes, polymers. These are all, when converted to bulk to nano, it is in the range of 1 to 100 nanometers. So these are called nanomaterials. And one more thing in the upper level is a bacteria, cancer cell, and pencil tip, and tennis ball. These are also some dimensions or size. Those are the beyond the nano size. That is a 10 power 3 to 10 power 8. Those are not called nanomaterials. Only within the range of 1 to 100 nanometers called nanomaterials. These are some of the specified examples in the field of pharmaceuticals like DNA, antibody, protein, and oligonucleotide virus. And beyond the pharmaceutical line, these fullerenes, dendrimers, quantum dots, and metal oxide nanoparticles, liposomes, polymers are the specified some of the examples under nanoscale size. And here, similarly, some more examples here. What is the range of the particular nanometers? For example, gold nanoparticle. Gold nanoparticle is a metal nanoparticle. It is absolutely, when converted to bulk arum chloride to gold nanoparticle, it is a 10 nanometer size, 10 or 5 nanometer. Then it is a exactly.
Sir, slide is not moving, sir.
Hello, sir.
Slide is not moving.
Slide is not showing, huh?
Not moving, sir. Okay.
Now it is okay, sir.
Okay, please carry on. Okay.
Okay. And some examples of specified examples under nanoscale size, that is 1 to 100 nanometers. Those are only gold nanoparticles, and carbon nanotubes are called nanometers. But virus are 1 micrometer, means 10 power minus 6 meters. It is not a nano range. And human hair also 100 micrometer of size, but it is also not nano. Then you compare what is the human hair size when compared to nano. This normal human hair is 100 micrometers. The nano is less than the human hair. That is a 1 nanometer. That is the best comparable example for the what is the nano, what is a micrometer of nanoparticles. And some of the large size metals also there. Those are not called nanometers. Like example, the watermelon and pencil tip or full stop or red blood cells and coins. These are all not in nano range. These are micro and normal meter ranges. And that is the introduction of the nanomaterials. Now we are types of nanoparticles and its properties. And how many types of nanoparticles? Every nanoparticle under these 4 type of nanostructures or nanomaterials. Those are the 0-dimensional, 1-dimensional, 2-dimensional, 3-dimensional. In every nanomaterials under classified these categories: 0-dimensional, 1D, 2D, 3D structures. Now, what is the difference between different dimensions of nanostructures? Now here 0-dimensional. 0-dimensional is a like fullerenes. Fullerenes, how it appears like a round balls. There is no dimension. So that is a 0-dimensional nanostructures. As well as nanoparticles and nanoporous materials. Also, there is no specified dimensions. Sometimes it has some different dimensions based upon the different type of nanometer. For example, metal nanoparticles, some different sizes. And metal oxide nanoparticles have different shapes and sizes. So, in general, 0-dimensional is example for the fullerenes and the nanoparticles and nanoporous materials. And 1-dimensional nanostructures are, it is less than 100 nanometers. Less than means 1 to 100 nanometers as their size. And there's some different of layers. Layers mean in their structures, like layered structures, graphenes. Graphene has a layered structure. Such type of also it is called as a 1-dimensional nanostructures. And the second 2-dimensionals are the different one from the 0-dimensional, 1-dimensional. It is a nano ribbons, nanotubes, carbon nanotubes. Carbon nanotubes are the several types are there. Multi-carbon nanotubes and nano horns and nano wires. Those are the 2-dimensional shape of their structures. And graphene is a layered structure and it is a rolled graphene sheets. Rolled graphene sheets also under 2-dimensional nanostructures. And the 3-dimensional nanostructures are the that is a different 3D shape that is only visible in the specified dimensions. These are the different types of the dimensions based upon their dimensions or shape of the nanomaterials are 4 types. Here I am showing some examples of the different dimensions of nanomaterials. Now we are showing the fullerenes. Fullerenes has a round shaped nanomaterials. Those are under 0-dimensionals. There is no specified 1D, 2D, 3D. So carbon nanotubes. Carbon nanotubes are the 2-dimensional nanostructures, and graphene is the some layered structures. These carbon nanotubes are formed by the layered structures and surround means of a rolled graphene sheets are converted to carbon nanotubes. And carbon dots also under 0-dimensional and nano diamonds are the 3D dimensional. 3D, for example, is a nano diamonds. Those are the only visually 3D shape. And one more example is there. 0 dimensions is the quantum dots. Dots is in a spherical shape. There is no specified dimensions. And nanotubes, and nanofilms and carbon nanotubes and rolled graphene sheets are 2-dimensional, and 3-dimensional is the nanocrystalline materials like nano diamonds is a 3D dimensional nanostructures. And some more examples are based upon the previous slide. The clusters, nano clusters also 0-dimensional. There is no specific dimensions in their shape or structure. And the examples for 1D is the nanotubes, nanorods. And 2D are the different of layer structures. When, for example, I am saying here, graphene sheets, rolling of graphene sheets are nano sheets. Those are the 2-dimensional sheets. That is under category of 2-dimensional. And polycrystalline materials means different of crystals combined and form a polycrystals. That is a three-dimensional nanostructures. And these are some examples. I'm explaining it here. Different dimensions are different shape of the nanomaterials and their classification. And here also the rolling of graphene sheets. The first one is the picture D is that just graphene sheets are rolling by the different methods to form nano sheets. That is a two-dimensional. These are picture D, E, F is a two-dimensional, and picture F is the three-dimensional. It's a different rolling and view of the 3D shape is the examples for the 3D and 2D dimensions nanostructures. These nanorods, nanoshells, nano cages is also one of the category under one-dimensional and two-dimensional nanostructures. This is the rolling nanosheets to form from the graphene layers. That is a one-dimensional to two-dimensional nanosheets by the rolling of graphene sheets. These are called nanosheets. Several types of nanoparticles, different forms. Those are nano sheets, nano ribbons, nano cages, and nano rods, and nano particles and nano composites also. Means not only particular dimension, different dimensions are called different of nanostructures. And nowadays graphene sheets is a evergreen for the every different of applications, like sodium ion batteries, and means batteries, sodium ion, not only sodium ion, lithium ion batteries, and supercapacitors and semiconductor preparations, and in electrochemical catalytic applications also by using graphene nanosheets. And recently it has been a Nobel award for the based upon the graphene nanosheets to form a supercomputers or supercapacitors. Hello? అవును.
ఇప్పుడు సిక్స్త్ స్లైడ్ సైజ్ ఆఫ్ నానో అవునవును సార్, అవును సార్. సార్ అన్మ్యూట్ చేస్తాను, మ్యూట్ చేస్తాను, అన్మ్యూట్ చేస్తున్నాను సార్. అంతే. అన్మ్యూట్ అయింది సార్, మాట్లాడచ్చు.
సార్ మీరు
సార్ మీరు టాస్క్ బార్లో
మీరు అన్మ్యూట్ చేస్తారు, మీరే ఆన్ చేయాలి సార్.
అన్మ్యూట్ అయింది సార్, మాట్లాడచ్చు సార్. అన్మ్యూట్ అయింది, మాట్లాడు.
హలో
సార్, అన్మ్యూట్ అయింది.
Okay, I'm audible to you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. These are the types of the nanomaterials based upon zero dimensional, one dimensional, two dimensional, and three dimensional. Different based upon their shapes and sizes, it will be classified. For example, zero dimensional is the fullerenes, nanoparticles, and nanoporous materials are the under zero dimensional. For example, fullerenes are the round ball shaped nanomaterials. Those are not particular dimensions, so those are the zero dimensional. One dimensional is the 1 to 100 nanometer range of the particles are one dimensional. And the second two dimensional is the nano tubes and nano ribbons and nano wires. Those are called for the two dimensional under category of the graphene nanosheets. And graphene nanosheets as well as carbon nanotubes also two dimensional nanostructures. And three dimensionals are the under 3D images. For example, nano diamonds. Those are the different shapes and in the three dimensional. So these are the classification of the nanostructures based upon their dimensions. These are some of the examples of different dimensions of nanoparticles. Some polarins and nanocarbon nanotubes and graphene sheets, carbon dots and nanodiamonds are the 0, 1 dimensional, 2 dimensional, 3 dimensional category. And one more example is the quantum dots are the quantum dots or polarins are 0 dimensional, and nano tubes are the 1 dimensional, and nano films are carbon nanotubes are rolled graphene nanosheets are 2 dimensional, and 3 dimensional is the nano polycrystalline materials, those are nano diamonds. These are some of the examples under different categories of nanomaterials. These are also some of the examples like clusters are quantum dots and under 0 dimensional, nanotubes, nanorods, nanofibers are 1 dimensional, and 2 dimensional is the based upon layered structures. Layered structures are the graphene sheets and rolled graphene sheets, and carbon nanotubes are 2 dimensional, and polycrystals and nanodiamonds are the 3 dimensional nanostructures. These are some of the examples of different type of nanostructures under 0 dimensional, 1 dimensional, 2 dimensional, 3 dimensional. These are also some examples under different categories: nano rods, nano shells, nano cages, and rolled graphene sheets, and normal graphene nanosheets, and nano diamonds. These are also different examples for the different dimensions of the nanomaterials. These are the nano sheets. It was prepared by the layered graphene sheets by the rolling of the nano sheets. And nowadays, graphene nanosheets are major applications in the field of batteries preparation. That is the sodium-ion batteries, lithium-ion batteries, and supercapacitors, and semiconductor materials also prepared by using of graphene nanosheets due to the strength is very high compared to the another materials. These are the some of the images are transmission electron microscope images of various types of nanomaterials. In the picture A is the nano dots or quantum dots. It is a spherical shape nature, that is a quantum dot. B is the nano rods. Nano rods are nano cages type low. There is a second category, and third one is the spherical nature. And compared to the figure A, figure C is the high size. Size is very increases compared to A. And some another pictures of those nano flowers and nano stars and nano sheets and nano cubes. These are some of the examples of different of materials of their structures or shapes in their dimensions. And one more classification, nano composites. Nano composites are formed by the combination of the different type of nanomaterials to form a nano composite. That is based upon the, for example, A type of nanomaterial, B type of nanomaterial combined with A plus B, like A to B, is a formation of a nanocomposites. It's based upon the dipole-dipole interactions of the different type of nanomaterials or different components in the composition. And what is the difference between the nanoparticles and bulk materials? Absolutely, bulk materials have no large surface area, so there is no quantum effects. When compared to the nanoparticles are converted to nanoparticles from the bulk materials, those are the different formation of the properties, like surface area is gradually enhancing and quantum effects may completely vary from the bulk materials. And based upon these two factors, surface area, quantum effects, it will enhance lot of applications and based upon the size of the nanoparticles compared to bulk materials. That is the advantage of the nanomaterials from the bulk materials. And the next one is the how to prepare nanomaterials. Majorly all of the nanomaterials prepared by the two approaches. One is the top down approach and bottom up approach. Top down means higher bulk materials to convert to nano size by various techniques. That is a top down, means from top to down. Top is the higher size of the materials, a large size of materials to convert small size. And bottom up approach means a small size but different type of atoms to combine clusters and to form nano size. It's absolutely top down and bottom up, not based on size but shape of the dimensions. Top down is the bulk materials to convert to nanomaterials. Bottom up approach is the atoms or molecules to convert nanoparticles. These only two techniques may involved into prepare of the all nanomaterials. This is also a clear-cut picture about the top-down approach and the bottom-up approach. That is the bulk material, it's a large size. Is converted into the small-sized particles like nanoparticles is called a top-down approach. This is based upon the mechanical milling, etching, laser ablation, and sputtering electronics. These are the techniques involved in the top-down approach. And the bottom-up approach is the molecules or atoms to combine with each other to form clusters based upon their growthing of nucleation. And after that, it converted to the nanoparticles. That is the bottom-up approach. Some examples are there from bottom-up approach. Those are the Sol-Gel method and chemical reduction, grain synthesis, laser pyrolysis, and spinning, supercritical fluid system, like that. Some of the examples for the bottom-up approach and top-down approach. These are the two different techniques involved in the preparation of nanomaterials. In detail, various methods are involved to prepare nanomaterials. Not only this time, and another synthetic methods also involved, but those are not essential for the different structure and controlled size of the nanomaterials. These are the important techniques to prepare nanomaterials. One is the co-precipitation method, second one is the hydrothermal method, third one is the servothermal method, fourth one is the sonochemical irradiation method, fifth one microwave irradiation method, sixth one Sol-Gel method, seven is the chemical vapor deposition method, 8 is the electro deposition method, 9 is the plasma marking method, and the last one is the ball milling method. These are the different techniques involved in different instrumentation as well as different procedure to prepare different type of materials. For example, every method has some specific nature to prepare specific type of nanomaterials. We will see in detail one by one. First one is a co-precipitation method. Co-precipitation method is a very simple technique among all the methods. For example, when you are preparing to the nanomaterials, first you take the anionic solution and cationic solution. Combined with both of them and to form as a nucleation and growth. After that, only under constant stirring only. There is no proper experimental setup for the co-precipitation method. Just you take in one reaction vessel to add anion solution, cationic solution, and to develop a nucleation and growth to form a on precipitation. The precipitation is continuously stirring to break the bonds between the anionic and cationic solution to form the nanomaterials. It's a simple technique by using only magnetic stirrer by addition of the anionic or cationic solution to form nanomaterials. It is a co-precipitation method is useful to prepare metal nanoparticles, metal oxide nanoparticles, and metal sulfide nanoparticles. The co-precipitation method is the best for these only different type of materials, metal or metal oxide or metal sulfide nanoparticles. And second one is the hydrothermal method. And all of the lot of biology students, life science students, they know about the autoclave. Hydrothermal method is completely based on the autoclave. Autoclave is a simultaneously generation of a temperature and pressure. This is a major involved in hydrothermal method is the simultaneously development of temperature and pressure at a time. There is a major technique in hydrothermal method, and hydro means water molecule. Here in hydrothermal method, the solvent is water only. If you want to add some water into the reaction vessel, it will be automatically carried out to form the nanomaterials. Just you take one reaction vessel to add all precursors, and it will be put into the autoclave, and a particular temperature and particular pressure you set up in the autoclave, and continuously monitoring by the hydrothermal method to form different type of the nanomaterials. This is also hydrothermal method is useful for the metal oxide nanoparticles the best. Hydrothermal method is useful for the best one, metal oxide, to give a particular dimensions and particular shape of the nanostructures. You prepare by the hydrothermal method. And third one is the salvothermal method. Salvothermal method is also similar technique as per hydrothermal method. Why? Because the difference of the hydrothermal and salvothermal is the hydrothermal is only the solvent is water, and the salvothermal is the any one of the solvent you should add into the reaction precursor and to give the different type of nanomaterials. The difference between hydrothermal and salvothermal is the only solvent may be involved different from the hydrothermal and salvothermal. It is also based upon autoclave, simultaneously development of temperature and pressure particular time. You should prepare different sizes, different shapes of the nanomaterials. Fourth one is the sonochemical method. Sonochemical method is nothing but called as a ultrasound irradiation method. Sonochemical method is called as a ultrasound irradiation method. The below one is the instrument of sonicator. It is a simultaneously development of a ultrasonic frequency, ultrasonic waves involved in the preparation of nanomaterials. The setup is that you have taken a reaction vessel to combine all reactant precursors should be added to the vessel, and you put into the sonochemical instrument or ultrasonicator. Then alternatively it should be operated by the setting parameters of ultrasonic frequency, time and temperature. These three parameters should be applied. Then after particular time it will be converted to bulk material to nanomaterials. After that, a normal procedure to form a precipitation, to filter and to grind it, to dry it and grind it, and to operate for the further applications. Sonochemical method majorly involved in the ultrasonic waves involved in the sonochemical or ultrasonicator. And what are the benefits for the sonochemical method compared to previous methods? Very lesser time, means within the 1 minute, 2 minutes the reaction will be completed based upon the material. This is a precaution. Based on the material, you should prepare within the 5 minutes you should form nanoparticles from the bulk materials. Then is the efficient energy also uses for the sonochemical method. This is the best for the preparation of different coating of nanoparticles. For example, we are already know about some examples, silver coated Teflon or aram coated Teflon, like means coating material should be prepared by the sonochemical method. It is also particular shape and particular size you should prepare based on the ultrasonic frequency you should be used in the preparation method. And one more is the microwave irradiation method. Microwave irradiation method is also one of the technique to prepare nanomaterials. It is also very less time required to form a nanomaterials based upon the microwaves involved in the preparation of nanomaterials. Those microwaves should convert to the bulk materials to dispose or degrade their molecular bonds into the reaction vessel to form nanoparticles or nano-sized particles. It is also based upon microwave frequency as well as time. It is also very less time required to form nanomaterials. For example, you should use 160 megawatts power, different powers, microwave frequency, different powers and different times may be involved in the formation of different type of nanostructures. You also that some steps are there, that is the heat energy. In microwave energy is converted to heat energy to form by the microwave radiation, and the heat energy is absorbed by the reaction vessel or reaction precursors or sample. After that, creation of high vapor pressure due to mature evaporation to convert small size nanoparticles. This is the method involved in the microwave irradiation method. It is also used for the particular shape or particular size you want to be prepare nanostructures. And the sixth one is the very oldest method, and a lot of nanomaterials and most of the nanomaterials prepared by the sol gel method. It's a very easy technique. There is no proper instrumentation for this. Remaining all are hydrothermal and salvothermal, sonochemical and microwave irradiation methods are required, some apparatus or instrumentation. But sol gel method, there is no proper instrumentation is not required to prepare nanomaterials. Simply, you should add precursors and solvents and to form a sol. Sol means a colloidal solution. The colloidal solution to convert the gel formation by addition of gelatin. After gelatin added to the precursor solution to form gel, sol to gel. After formation of the gel by the gelation technique, then those are the different techniques you have to use. That is supercritical dyeing, thermal drying, and freeze drying based upon their aerosols, xerosols, and cyrogels. After that, you dry it and you convert the products. This is a very simple technique. There is no proper instrumentation is not required. It is a simply laboratory. Any laboratory should be prepared different nanomaterials. In the starting stage, reactants will convert to sol. Sol is a colloidal solution. After that colloidal solution, addition of the gelatin solution to form a gel by the gelation technique. That gelation technique should be converted to the different techniques by the aerosol, xerosol, and cyrosol after convert the final nanomaterials. These are the sol gel method to form different nanostructures. It is also best useful for the preparation of metal oxide nanoparticles like titanium dioxide, silica, alumina, and tungsten oxide and zinc oxide type of materials should be useful for this technique, sol gel method. What is the advantage of sol gel method? First thing, instrumentation is not required and very less time and low temperature process, and you should be prepared metal oxides in different forms like nano plates, nano discs, nano powders, and thin films also prepared by the sol gel method. And one more nano type of nanomaterials should be prepared by the sol gel method, that is alloys or composites. Alloys are the different type of materials should combine to form alloys or composites. It is also useful for the sol gel method. and it can be attached to most other materials like plastic, paper, and metals. Conversion of nanomaterials. It is also useful for the sol gel method, and optical quality is high enhanced as well as purity also achieved high yield, high purity for the sol gel method. Seventh one is the chemical vapor deposition method. Among them, all synthetic methods, this chemical vapor deposition method involved in the gas phase. Remaining all are solid phase or liquid phase. But chemical vapor deposition method is involved in the gas phase reactions. Means you applied for the inert gases like nitrogen or argon gases should be applied for the reactant solution or precursor solution. Then some required instrumentation. After that, formation of the nanoparticles to evaluate the gas outlet as well as to form the products by in phase of only gas method only. Gas should be applied for the reactants to convert nanoparticles from the bulk materials involved in the chemical vapor deposition method. And one more advantage for this chemical vapor deposition method should combining of controlling various methods, like for example, temperature controlled, pressure controlled, and substrate controlled, and precursor controlled, time controlled, and gas control, and activate in manner also you should prepare different types of the chemical vapor deposition techniques to prepare various nanomaterials. And next one is the electrode deposition method. Electrode deposition method is based upon the electrodes. Electrochemical energy should be introduced to the formation of nanomaterials from the bulk materials. Here, electrolyte solution with our nanomaterial solution combined in the reaction vessel to apply anode material and cathode material should apply electrical energy. It will convert it to bulk materials. The breaking are involved the randomly dispersed of their bonds to prepare nanomaterials. This method, electrode deposition method, is the best and useful for the metal nanoparticles. Metal means silver nanoparticle, gold nanoparticle, palladium nanoparticle, nickel nanoparticle. This type of material should be best application for the preparation of electrode deposition method. And plasma arcing method. Among all the methods, this is one of the different and some critical method. It's based upon plasma arcing method. Plasma is ionized gas. It is involved in the mass spectrometry. Ionized gases involved in the preparation of nanomaterials. It is also related to electrochemical energy. It should also be involved anodes and cathodes in their directions. By the arcing of plasma, by dispersion of the bonds or breaking of the bonds involved in the bulk materials to convert to nanomaterials, and one electrode to anode to cathode or cathode to anode, the electrical energy is dispersing to form a different type of nanostructures. Then here, plasma arcing method is the best example for the preparation of carbon nanotubes. This plasma arcing method is best for the carbon nanotubes. Different type of carbon nanotubes like multi-walled, single-walled. Single-walled carbon nanotubes are there, and multi-walled carbon nanotubes also prepared by using of plasma arcing method. And the final one is the ball milling method. Ball milling method means it is useful for the spherical shape of the nanomaterials is the best technique. That is the ball milling method. What is the technique involved in the ball milling method is the rupturing or deformation of the molecules or atoms to convert small size molecules from the large size or bulk materials. This is a technique is involved by the elastic deformations or plastic deformations to combine to rupture or bombarding, and it will be useful for the preparation of ceramic nanomaterials. This ball milling method is useful for the advanced application for the preparation of ceramic nanomaterials. Ceramic nanomaterials means of alumina type and silica type of ceramic nanomaterials to combine ceramics. The ball milling method is useful for the preparation of ceramic nanomaterials. What is some of the advantages and disadvantages also there for the ball milling method? The advantages are it should be prepared very less size of the particles. Very less size means 2 to 20 nanometer size. Actually, nanometer range is a 1 to 100 nanometer, but by this method, you should prepare 2 to 20 nanometer size based upon the ball milling method. And if size is very less means surface area increases, so applications also gradually increases, and it is an inexpensive and easy process to operate the ball milling method. And some advantages also and disadvantages also there. That is the when we are using ball milling method to prepare nanomaterials, there is no particular shape, means irregular shape of the particles are formed. Some shapes are spherical, some like rods, some like means different shape of the nanoparticles are formed by the ball milling method. When we are prepare a controlled size, it's not useful for the ball milling method. And one more is some crystal defects also there by nanomaterials by using of this technique, ball milling methods. And finally, I am explaining it here. These are the synthetic techniques for the nanomaterials by various instrumentation and methodology, as well as for the different type of nanomaterials. These techniques are involved to various synthesis of nanomaterials. And the next category, that is the characterization techniques. After preparation of the nanomaterials, next step is the confirmation of the nanomaterials. Confirmation of the nanomaterials based on these techniques. Basically, these are the basic techniques to confirm your prepared nanomaterial is nano range or not. Then those techniques are UV visible electronic absorption spectroscopy and FTI or Fourier transform infrared spectrometer and powder XRD instrument and scanning electron microscope, transmission electron microscope, and thermal gravimetry analysis or differential thermal analysis instrument, zeta potential, and BET analyzer, that is the surface area measurement techniques. These are the essential to confirm the formation of nanomaterials. Then I will explain one by one. By using of UV visible spectrometer, when we are prepared nanomaterials, either liquid or solid modes, means two different of nanomaterials are formed, homogeneous or heterogeneous, solid particles or liquid particles. Then UV visible spectrophotometer has two categories. Like you can use directly liquid solution to analyze UV visible spectrometer to detect the maximum absorption wavelength. In case solid particles, how you can examine UV visible spectrophotometer? That is to combine with one of the barium sulfate is inert material that is added to our sample and coated with them and input in UV visible spectrophotometer, then it will give the maximum absorption wavelength at particular sample. From this UV visible spectrophotometer, primarily we confirm the nanomaterial based upon their wavelength. Wavelength you should find out. Then from the wavelength, you can calculate the band gap of values. Band gap of values from the wavelength to confirm the synthesized nanomaterials. Means majorly UV visible spectrophotometer is useful for the detection of maximum absorption wavelength as well as band gap of the material. Second one is the FTIR spectrophotometer. FTIR spectrophotometer is useful for the analysis of functional groups involved in the sample. For example, here I am for example, one plant extract or leaf extract or seed extract. Any plant related material should be involved in the preparation of nanomaterials. In plant material has a lot of flavonoids, polyphenols, and a lot of amino groups, hydroxy groups are there. After the formation of the nanomaterials, it will be characterized by the FTR spectrophotometer, and some absorption peaks are involved. Those are identified by the different functional groups and their respective wave number values. I am showing here some examples. This one, the first one is the UV visible absorption spectra. When we are taking a UV visible spectrophotometer, it will give the output is like this, the wavelength versus absorbance. It will give the maximum absorption wavelength value is find out. Then based upon the maximum absorption wavelength value to Planck's equation is equals to SC by lambda formula, then you can calculate band gap values. And FTR spectra. FTR spectra also here some strong absorption peaks, some broad absorption peaks, some low intensity peaks are there. Those are the based on the functional groups involved in the material. That is the FTIR spectra purpose. And next one is the XRD instrument. From the XRD technique, we should found the crystal structure of the materials. For example, simple cubic or orthorhombic or monoclinic, like it means different structures of nanomaterials should be found by the XRD instrument. The output of the XRD of the materials is like this, based upon their crystal planes. Crystal planes include Miller indices. Based upon crystal planes, you should observe the structure of the prepared nanomaterials. And in nanotechnology, scanning electron microscope, transmission electron microscope is majorly involved to confirmation of the size of the nanomaterials. For example, scanning electron microscope is the surface phenomena, means directly the electronic waves are compared to the surface of the sample. But transmission electron microscope is the in-depth of the particles. So some pictures are here. This is a SEM image and this is a TEM image. SEM image is the only surface of the particles. Surface of the particles means only what is the surface area is involved in the nanomaterial should be calculated by the SEM. But TEM is the surface area as well as the what is the dimensions, means a 2 nanometer, a 3 nanometer, a 10 nanometer also should calculate by the TEM images. These are the two techniques to determine the size of the particles and shape of the particles, like spherical shape, nano rods, or nano cases, or nano flowers, or nano diamonds, like that. Means shape and size of the nanomaterials were analyzed by the scanning electron microscope and transmission electron microscope. Next one is the TGA and DTA instrument, thermal gravimetry analysis and differential thermal analysis. These techniques are involved to analysis of the thermal stability of the prepared nanomaterials. Thermal stability means, for example, we prepared one nanomaterial, that is a zinc oxide nanomaterial, titanium dioxide nanomaterials. But we check actually, we want to check how much temperature should be involved to stable the prepared nanomaterials. For example, we applied for the 1000 degrees centigrade or 800 degrees centigrade. How much degraded at different of temperature levels should be observed by the TGA DTA analysis. This is the example. The TGA applied for the 750 degrees centigrade is gradually decreases up to 100% to 70%, means 30% degradation are thermally unstable at 750 degree centigrade. It is observed by the thermal gravimetry analysis. And from DTA, differential thermal analysis, we should found the exothermic reaction or endothermic reaction should be found by the differential thermal analysis. Means major purpose of the TGA DTA analysis or instrument is thermal stability or exothermic endothermic reactions. Maybe you find the synthesized nanomaterials. Next one is the Zeta potential analyzer. Zeta potential analyzer is we just only observe the zeta potential of the prepared nanomaterial, that is a positive energy or negative energy should be found. Here, for example, is there This is zeta potential analysis. Their zeta potential values, for example, 30 plus 30 millivolts or 40 or minus, means positive or negative potentials can be found by the synthesized nanomaterials based upon the zeta potential analysis. This technique. And final one is the bet analyzer. Bet analyzer is the surface area analysis. It's a major important for the nanotechnology development. That is the bet analyzer. That is a surface properties like the surface area. How much of surface area is increases means that is the less size of the nanoparticles. You should found the bet analyzer. This is the technique involved in surface area analysis. Should be calculate surface area of the synthesized nanoparticles. These are the different techniques or characterization techniques or analytical or spectroscopic instruments should evaluate their band gap values, what are the functional groups involved in the nanomaterial, their structures, shape, size, as well as thermal stability, surface area, and their potential, zeta potential energies. These are all you should know from these techniques by the prepared nanomaterials. And the next category is the properties of the nanomaterials. Properties of the nanomaterials are the nanomaterials compared to the bulk is enhancing their properties due to size or quantum effects. Based upon the size and quantum effects, we should enhance the properties of nanomaterials. In case which type of properties may be enhancing means here the different type of properties I am explaining here: mechanical properties, catalytic properties, magnetic properties, optical properties, surface area properties, quantum effect properties, and thermal electrical conductivity properties, and finally biological properties. These are all properties should be enhanced compared to bulk materials due to size dimensions or size variation from the bulk to nano, as well as quantum effects. Quantum effects also may involve to increase their properties. And from the mechanical properties, we should know the grain boundaries and the bulk materials to convert the nanomaterials, their ground boundaries by using of mechanical energies. And catalytic properties are the nowadays catalytic properties are majorly enhancing in nanotechnology developments. Those are the reducing environmental pollution and reducing some toxicity in the water treatment and preparation of the different of sensors, which are like involved in their catalytic properties. Magnetic properties to form a superconductors or supermagnetic materials or capacitors. And optical materials are the semiconductor materials. Optical is electronic and electric field. It may be useful to prepare different type of semiconductor materials. Should be involved in the preparation of devices, electronic devices. That is the optical properties. Surface area properties are the for example, two type of materials, either bulk and small. Bulk type of materials has less surface area compared to nano. So automatically surface area enhances means their properties also increases for the catalytic. Why? Because surface area increases, the active sites on the surface of the material is also increases. Active site increases means the catalytic properties means some reactants or reagents are involved or enter into the active sites to convert the products. Means surface area enhances, then automatically catalytic applications also increases. Quantum effects means completely based upon the size of the nanomaterials. And thermal electrical properties also by the stability of thermal stability should found, and electrical conductivity measurements also involved in the prepared nanomaterials. And finally, our aim of the webinar, pharmaceutical applications of nanomaterials. Those are the pharmaceutical applications in the nanomaterials based upon the biological properties. Biological properties also greatly enhancing of the nanomaterials when converted to bulk materials. Now we're trying to go for the applications of the nanomaterials by the various fields. nowadays, till now, lot of applications are in greatly enhancing in different of fields like electronics and catalysis, photocatalysis, drug delivery systems, biomedical systems, environmental, agriculture, and energy applications. These are only some examples, but the vast of applications are there for the based on nanomaterials. And one more showing here. This is the very variation of the applications in field of nanoparticles in different of fields, like not only catalytic, not only sensing, not only biological. You can use the textiles, you can use in environmental and industrial applications and food packaging applications, agriculture fields, healthcare, biomedical, electronics, everywhere. And nanomaterials should be applied in anywhere in the application in the field of different of techniques. I will show some of the fields of applications only. This is the best example for the environmental application. Environmental application means in the one side is the toxic pollutants presence, another one is the toxic pollutants removed by the nanomaterials. What happens? One is the greenery and another one is the desert-like area. So when we are using nanomaterials to remove the pollutants from the environment, like a water medium or gas medium, whatever it is, to remove by using of nanomaterials, absolutely great achievement in the environment field. How it remove means by using of catalysis or photocatalysis techniques. For example, dye solutions and industrial pollutants is contaminated by the water. For example, some industrials are releasing water frequently based on their output. So, lot of toxic chemicals are involved in the industrial wastewater. Those industrial wastewater are taken by the industries by using of nanomaterials. After catalytic application, the catalysis was removed by the toxic pollutants to prepare as a environmental safety. This is a best example by using of nanomaterials to removal of toxic pollutants or toxic metal ions or mercury, lead. So the toxic metals also removed by the wastewater treatment to prepare purification of water by environmental pollution prevention. These are for the energy application. Energy application means lot of nanomaterials should be involved in the preparation of batteries and lithium ion battery, sodium ion battery, and lithium sulfur batteries. Like means the nowadays batteries are made useful for the any electronic companies and electronic gadgets. It is useful for the preparation of nanomaterials by using to electrical field. That is the energy applications also. And coming to the point, nanomaterials majorly advances in the medicinal field, means pharmaceutical field for the drug delivery applications. Now I am saying here proudly, when my PhD is doing with nanomaterials cancer treatment activity, that is a doxorubicin drug is one of the anti-cancer agent. Then we prepared some plant extracted nanomaterials by using of metal oxides. Those metal oxides are combined with the doxorubicin. It will be in vivo study, means animal studies and rats and mice. Then it will be greatly achieved to the reducing of cancer or toxicity of the cancer treatment may be involved. So now nanomaterials for drug delivery applications, different of drug delivery, not only single one. Some combination of the two drugs or more than two drugs to dissolution by application for the various fields like genome editing and characterizing a specific target of tumors and modeling and DNA cleavage and DNA bindings and its intracellular delivery and targeting immune cells and determining a pharmacokinetics of the diseases of a particular patients. Also, we observed by the using of nanomaterials. And basically, drug delivery applications should be useful for the preparation of nanomaterials. This is the cancer treatment. The different type of nanomaterials should be involved in the diagnostic field as well as targeting of the cancer stem cell, and after that the therapeutic or diagnosis by the particular area of the targeted cancer cell to prepare the to treatment the cancer diseases also by using of nanomaterials nowadays. And these also various nanomaterials for diagnosis and treatments, and not only cancer treatment, and several applications also involved by the several type of nanostructures. For example, carbon nanotubes, polymeric nanoparticles, and dendrimers, and lipids, liposomes, and metal nanoparticles, quantum dots, and metal oxides, and nanocomposites, and everything to prepare by the nanomaterials should be involved in the diagnosis or treatment of various diseases by human or animal. This is the one more achievement of the nanoparticles in nanomedicine field, that is the diagnosis of or treatment of diabetic also. Diabetes also maybe treatment has been done by using of nanomaterials, by using of various nanoparticles, not only a particular nanomaterial. You can use inorganic nanoparticles, polymeric nanoparticles, biosensors, and liposomes, macellase, and metal nanoparticles, metal oxides. Everything should be applicable for the treatment or diagnosis of the diabetes patients also. And nanoparticles for pharmaceutical applications also we can use for the gene delivery and gene sequencing, anti-cancer treatment, and bacterial viral infections of the colon, and cell imaging, and protection of the UV light from sunscreen solutions, and MRI scanning, etc. All of the diseases or pharmaceutical applications should be applied by using of nanomaterials. And recently, one more technical advancement, that is the nanorobots, preparation of nanorobots. The nanorobots are, first of all, the targeting the disease or effective cell of human body. Then after that, targeting to diagnose by the specified manner. And it's the nanorobots to treat genome sequencing as well as DNA cleavage or DNA binding interactions also involved by help of nanorobots. These are the all not only specified applications, some more applications also involved by using of nanomaterials. And finally, I am concluding here, nanotechnology is in everywhere, not only a specified field, in everywhere, in all fields, by using of nanomaterials should be developed their technologies. This is a presentation. I'm explaining about the synthesis and characterization, property, and applications of the nanomaterials. Please ask any questions if you want, if you know about the regarding nanomaterials.
ఇప్పుడు నువ్వు చెప్తాను.
I am requesting all the participants type the questions in the chat box now, or you can unmute and ask the questions. Once again, I am requesting all the participants type the questions in the chat box, or you can unmute and ask the questions.
Yeah, very good morning to you, Vasanta. Is nanomaterial used in the field of ionic liquids? Yeah, absolutely applicable for the ionic liquids also. That is the preparation of the various techniques, like some solvent method also you should prepare ionic liquids, and it is applicable for the various fields also. To generation of the new electronic device also, it can be useful for the ionic liquids. Any more?
Hope there is no further questions. We will
Thank you.
proceed to the last session of the day, vote of thanks.
Thank you, Dr. Ayodhya, for your wonderful presentation on pharmaceutical of nanomaterials and its application in different fields, especially in medicine. Nanomaterials is in everywhere. Thank you once again, Dr. Ayodhya.
Thank you, ma'am.
I feel honored and privileged to propose vote of thanks on this special occasion. I would like to thank today's resource person, Dr. Dasar Ayodhya sir, for his excellent and outstanding presentation. Sir, you enlightened us clearly about the introduction of nanomaterials, conversion of bulk materials into nanomaterials, types and examples of nanomaterials, different types of synthetic methods, characterization techniques such as spectroscopic and analytical techniques, properties of nanomaterials, and finally various applications of nanomaterials. Sir, today my words are not enough to express our gratitude for sharing your knowledge with us, sir. I convey my deep regards and heartfelt thanks to our correspondent, Dr. Sister Teresa Magade, for her support. My sincere thanks to Dr. Sister Shaini KP, Principal of our college, for help and support. A special thanks to convener of this international webinar, Dr. K. Nirmala Jyoti, HOD of Chemistry.
Thank you, ma'am.
Thank you all for attending this webinar with a great patience. We hope learned all and enjoyed the session. And we join with second session in tomorrow at 9:30 a.m. Thank you all.
Can I stop sharing, ma'am?
Thank you.
Okay, sir, sure.
Thank you, Ayodhya.
Thank you, sir. Thank you, ma'am.